And the last question is not a proof. We see the word solve, so this is more like chapter 6 and things we've done in the past. We want to solve an equation, 3 minus 3 cos x minus 2 sine squared x equals 0. So to begin with, we think about solving this, but we should notice that we have sine squared x and a cos x. Those are different trig functions. You can't factor, you can't use the quadratic formula if you have two different things. Okay? We can't change cos x to sine x, but we can change a squared one. So what I'm going to do is I'm going to start by rearranging and saying I can change that sine squared using my big idea to 1 minus cos squared x. And now my equation is just with cos. I can distribute that 2. So I would have 3 minus 3 cos x minus 2, and then minus times a minus would be plus 2 cos squared x equals 0. And I have some like terms, and I see that it's quadratic. So with quadratic equations, we like to write our term with the squared first, then minus 3 cos x, and then 3 minus 2 would be plus 1. And at this point, we have to decide, are we going to use our quadratic formula, or can we factor? If we can factor, that's always the fastest. So I'm going to look at this and see, can we factor? If we could factor, it would have to be 2 cos x and cos x as the only option to get 2 cos squared x. This is my favorite one. It's my favorite one for students to factor, because it really involves almost no thinking in factoring. Because can you see that the only option for 2 cos squared is 2 cos x and cos x? And the last one's a 1. The only option to multiply to get 1 with whole numbers is 1 and 1. And so now the only thing you'd have to worry about is your signs. They're either both positive or both negative. Questions?
Why is the 2 cos x positive when there was a negative in front of the original sign?
So here I'm distributing this, right?
Oh, okay.
And so that negative 2 out front would hit that other negative, making it positive. Okay. So now I look at my outside. I need a minus 3. They would both have to be negative, so that my outside is negative 2 minus another 1 gives me negative 3. I do a quick multiplication out to double check that it all works, and it factors beautifully. So now that it's factored, I can split it up. I know that this side would be cos x is equal to 1/2, and this side cos x is equal to 1. So I go to my unit circle and say, is a half on my unit circle? Yes. That is my pi over 3 family. So it's going to be in quadrant 1 and quadrant 4. Yes. And cos x equals 1. That happens at 0 and at 2 pi. And as normal, I'm in the middle of solving. I just, out of habit, I always solve first between 0 and 2 pi. That's a good thing, because if it's a general solution, you're set up for that. Now I'm going to go back and make sure I reread my question and see what was my domain. My domain for this one is that x is between 0 and 3 pi over 2, and 3 pi over 2 isn't included, but 0 is. So then when I go to my answers, I only, 0 to 3 pi over 2 is quadrants 1, 2, and 3. Can you see that we have to get rid of our quadrant 4 answer there? Because it's past 3 pi over 2. because 5 pi over 3 is in quadrant 4. And I also have to get rid of my 2 pi answer, because that's past 3 pi over 2 as well. So I solved like normal from 0 to 2 pi. Then I rechecked my domain. It was only between 0 and 3 pi over 2. So these are the only 2 answers. And I'll get you to circle question number 10 for practice.